Just a little bit of homework help for Unit 7, Lesson 1, Exponent Review, problems 1, 2, 5, and 6. Write the expression using an exponent. We have 1 times 7 times 7 times 7 times 7. And what we really need to look at is how many times am I multiplying the number 1 by the base 7? And what that'll tell us is when we look at that, this is going to tell us how many times or what my exponent is going to be. My base is 7 because that's what I'm multiplying times 1. The exponent tells us how many times I multiply 7 times 1, and I see 5 of them like this. When we type this into the box, we need to write 7, and then we use the caret button like this, and a 5. That caret button can be found on your number 6 key, and you press the button, the shift button, and then the 6 button at the same time, and then you'll get that caret button. And that's how we need to respond to that one. This next one, you'll notice it's in parentheses to begin with. That means when you type your answer, you'll need to have 4/5 also in parentheses before you raise it to its appropriate power. This one that's a decimal, the exact same thing. The base, 9 3/10, will need to be in parentheses before you raise it to its power. Part D, it says write an expression using an exponent. The number of coins Jada will have on the 8th day, that's important right there, on the 8th day if Jada started with 1 coin and the number of coins doubles every day. So that's going to tell us right there how our coin is doubling. That's going to tell us the base, or that our coin is doubling right there. That's our base value. The 8th day tells us how many days we're after, so this is our exponent. Now all you have to do is put that base there, raise it to a power, and send it to the right exponent for the 8th day, and you'll be all set. This next problem, part A, evaluate the expression. What we're after by evaluate means to simplify into a whole number or into an integer. In this case, since we're starting with the base, 2 to the 5th power means 1 times 2 times 2 times 2 times 2 times 2. I know that 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And so that's what I would put right here is 32. 3 to the 3rd power, simply 1 times 3 times 3 times 3. These should be pretty quickly accessible and done. To get 27, 4 to the 3rd, you can go ahead and do that one. 6 to the 2nd, 1/2 to the 4th is a little bit different. That 1/2 to the 4th, notice that it's in parentheses. It's going to look like this. And so when we multiply, we see the top becomes 1 to the 4th power, and the bottom becomes 2 to the 4th power. 1 to the 4th power is simply just 1, right? Because 1 times 1 times 1 times 1 is 1. And then 2 to the 4th power is kind of like saying 4 times 4, which would make that 16. And so that would be our value that we would have to put in there, 1/16. Okay, do the same thing with 1/3, and you're going to do awesome with it. We're going to skip this next one. We'll come down here to this one. It says the points 2, 4 and 6, 7 lie on a line. What is the slope of the line? Well, remember when we talk about the slope of the line, we're talking about rise over run, or the change in y divided by the change in x. There are a lot of different ways that you can set this up. The traditional method, finding the slope, is that y2 minus y1 divided by x sub 2 minus x sub 1. The way that we figure out x sub 1 and x sub 2 is we look at the two ordered pairs and we see which one has the x value that's lower. That would make this one ordered pair number 1, this one ordered pair number 2. Substitute those values in right here and we can find them. Another way to do this is to set it up in a table, x and y, and you have 2 and 4, 6 and 7, and you find the change. This is a change of +3. This is a change of +4. And we can put the rise over the run. So remember, this is your rise over here. This is your run over here. And make a nice ratio that's written as a fraction. Choose whichever one is correct for this situation. And then finally, this last one, you have two parts. Diagram A shows a pair of similar figures, one contained in the other. Name a point for a dilation that moves the larger figure to the smaller one. So we're talking about this. We're talking about, here's the smaller figure right here. And we're saying name a point for a dilation that makes the larger figure to the smaller one. So what we're asking for is, where is the center of dilation? I'll give you a full sentence there. Where is center of dilation? Okay, and that's what you need to pick. On part B, it says the diagram shows a pair of similar figures, one contained inside the other. Name a scale factor for a dilation that moves the larger figure to the smaller one. So when we talk about that, since this smaller one is inside of it, we want to go a scale factor that moves the larger to smaller. That means that my scale factor has to be less than 1. Because I want something that's going to be a fraction of the size. I have a couple of ways that I can measure this. I can measure corresponding sides, ED to BC. We'll CB. Okay. I can also measure this side over here, AD divided by AB. That's interesting. They both start with the point A. That might be a good hint for part A. Or I could even look, this one would be a lot harder, but I could look at AE divided by AC. And all of these ratios would actually be equal to each other if you have the right value. So that's it for your homework. Let me know how I can help. Send me a message and we'll get it taken care of. Have a great day.